All right, we'll give people another minute or two to add their name to the slides if they want to the notes document, and then we'll get started. All right, so maybe we should go ahead and get started at this point. So I'm Dan Katz from the University of Illinois. I guess I'm kind of chairing this. We're going to start with FOTUS, doing some discussion about what is FAIR and what's going on in FAIR for research software, and then we'll have some talks from a bunch of different projects. Then we'll have some discussion about what makes sense to do in terms of FAIR for machine learning. Do we need to do something? Are we all set? If we need to do something, do people want to help? And how do we actually go forward? So FOTUS, do you wanna go ahead and get started?
Sure, thanks, Dan. All right, so welcome everyone. So I will start by giving a very brief introduction of FAIR. I would say that I'm fairly certain, I'm not intending, that most of the participants here have a very good awareness of the FAIR principles, but mostly for, let's say, completeness purposes. The FAIR principles were essentially a set of guidelines, set of principles that were formulated and published formally in 2016, that are meant to ensure that data are shared in a way that it enables reuse both by human and by machines. In that sense, the FAIR principles, we have a few elements: definable, accessible, interoperable, and usable. Each of those principles were further refined by sub-principles, if you like axioms, that are referring to the different parts that are relevant to the major principle corresponding to those. If we look a bit more into the FAIR principles for data, there's been a lot of discussions there about how they can be applied, implementations, and so forth. However, if we are looking at the research software, there are a bit of a gap there. The FAIR principles by themselves are intended to apply to pretty much any kind of research digital object, if you like. There has been a lot of efforts, also a lot within RDA to that end. Looking at software, however, there are some characteristics that are not unique, that are not the same, if you like, with data. So software is not just data. So there is a unique need here to see how the FAIR principles can be adopted for research software. There has been some work already for FAIR for research software. For example, there was a dedicated session in P15 in November 2019, and there was also an article published around it, which is sort of the first outline, first effort to define the FAIR principle for research software. There are a lot of international works to this end. There's a software sustainability effort around that. There is the software code activity around it. There are events within the literature community, and a lot of different infrastructures that are trying to work to that end. There are a lot of similar initiatives and outcomes in the past. This is definitely not exhaustive list of similar outcomes that have touched upon how fairness can be applied to not data, be that for software, for workflows, about training for those things, and so forth. So there is definitely some work done there. Looking for research software specifically, RDA has a working group on FAIR for research software, which incidentally the corresponding session was just before this one, and a lot of the members that are participants in the session are also, I think they were present in the previous one. So the idea was to have a working group that is a joint force between the RDA, Force 11, and the Research Software Alliance in order to identify and effectively define FAIR principles for research software. This is currently an ongoing effort. In the previous case, we had a discussion on how particular principles can be identified, but the main focus of the working group itself is to define the adaptation and adoption of the FAIR principles for research software. There are some interesting recommendations that have come up in different cases. For example, there's a recommendation from the EOSC that is defining a lot of the points that the FAIR guidelines need to be applied to a lot of digital objects, and they refer also to the efforts of the FAIR research software, as well as the one that was defined by the French National Committee for Open Science, and also defined that the specific nature of software is recognized as part of it, and the FAIR aspects are also clearly identified. So in that sense, this focus group has started with a lot of energy, if you like. There were 4 subgroups that were identified that were looking at different perspectives of the work towards defining these FAIR principles. The first was to review what can be an interpretation, a redefinition of the FAIR principles for research software without looking different similar work. The second one was to look about FAIR work in different contexts. For example, what could be incorporated in the FAIR interpretation for research software based on other works. A dedicated subgroup was looking at the actual definition of research software with some very interesting outcomes along the way. And also a distinct effort was to review what are the upcoming and the most recent studies around FAIR software and how to take them into consideration. All in all, the focus group is now it's closing to a version 1 of this definition, which will be coming up to a community discussion. But the important element that I want to highlight, and it's relevant to this session as well, is that there has been a lot of discussions on whether the FAIR principles for data, as they are or easily defined for data, can be or should be adapted for research software. And I think that a very similar discussion is absolutely relevant for machine learning. And like that, I will yield the floor to Dan.
Okay, thank you. Yeah, so can we go to the next slide? All right, so just kind of thinking about this from a high level, one question is how do we deal with FAIR and machine learning models? So the original FAIR principles, which sometimes I call the FAIR data principles, claim to apply to scholarly digital research objects, but they actually focus very strongly on metadata and data. And so we have the FAIR for Research Software group, which Fotis has just talked about, that's been looking at how do we translate and interpret these principles for research software. And the question is, do we need to do something similar for machine learning models? Are machine learning models data? So can you think of them just as a set of parameters and options that go with a particular framework, in which case maybe they're data? Can you think of them as software? They're an executable object that takes some input and provides some output, or maybe there's something different than this. And so this is really the kind of the question of this session. So, if we think about how FAIR applies, a lot of the elements of FAIR for data are really dependent on archival repositories, things like Zenodo or repositories that are in Re3 data. These repositories hold the data itself as well as the metadata, and they provide the search, the findable, and the accessible capabilities. Software ends up being different because it's typically not shared via archival repositories, but it's instead uses social coding platforms like GitHub or package management systems like PyPy and CRAN. And so if we think about this for machine learning models, how would we expect machine learning models to be deposited and searched and accessed? Is that via repositories? Is it via executable platforms? Is it through something else? And then we have the fact, as Siri, just put in as a comment, that that these these models and training data and other things are all linked together, and maybe they should be shared together, or maybe they should be shared separately. So this is a question. Next. So what we're going to do in the rest of the session is to learn about what some projects are doing. There's a list of these projects here, and they're also in the agenda. And then we will talk in the last half hour, basically, about what we can do next. So we're going to have a series of roughly 5-minute talks with a couple of minutes for questions after each one, and then half an hour of discussion about, is this a good topic? Should we propose something within RDA, an interest group or a working group? Who else should be involved that we haven't talked about here? And if we did propose this, who would want to lead or co-lead it? So let's get to that. So we'll start with a presentation on Dlhub from Aristana.
All right, great. Thank you, Dan. Just give me 1 second to share my screen. Okay. Can you all see just my slides? I'll take that as a yes. Yes, okay, cool. Thank you. Sorry, I can't see you guys at the same time as I'm presenting, so it's kind of funny. But all right, hello everyone. My name is Ari. Thank you for coming. I'm with the Globus Labs group at the University of Chicago, and today I'll be talking about a fair approach to data and machine learning in materials science. So data and machine learning are becoming key drivers of scientific progress, as I'm sure we've all seen. There's been dramatic growth in the last 5 to 6 years alone in the use of machine learning in material science, chemistry, and physics. The number of the number of publications in material science that use machine learning almost doubled from 2019 to 2020, shown by the CAGR, and more than doubled in 2018 to 2020. So we have lots of models and lots of data, but what can we actually do with them? How can we utilize these models, utilize these machine learning gains in our own research? So for a given study, let's say you want to reproduce their work, you might ask yourself, where's the code? Where are the models, and where are the training data? And how can I actually reproduce these results on my own? And without the answers to these questions, it can be hard to make progress in our own research. As I'm sure we've all experienced, often it can be hard to find the models or data if they're even published with the study. Once you have them, they can be difficult to run, especially with Python. There are always dependency issues. And even if you can run it on your machine, the results often differ from the studies depending on the hyperparameters you chose or the architecture of your machine, etc. So unfortunately, often after a paper is published, the machine learning models just wind up in the trash and are not really usable for the community. It's not that helpful. So we created Dlhub, the Data and Learning Hub for Science, for FAIR models. It's a one-stop shop to find, share, publish, and run machine learning models in the cloud. So if a user wants to publish a model, they can take any Python model developed via TensorFlow, Keras, PyTorch, etc., and upload it using our command line interface to Dlhub. On the back end, Dlhub creates a container to run the model in the cloud. And then the model is accessible via dlhub.org, our website, or our Python SDK. The model gets a landing page on the website and a DOI for easy citation. And the publisher can access the model at any time via our API. And then a user that wants to find, discover, or run a model can look it up in our model catalog, again, using either the website or the SDK, and then directly run it in the cloud, just like a Jupyter notebook. So for example, let's say you want to reproduce this study by Cherukara et al. First, you'd find the names of the relevant model or models, and you'd look them up on the website or using the SDK. And so here we have the user N prime uploaded 2 models related to this paper. And then in just a few lines of code, you can call dl.run on whatever data you have and get your predictions and plot them. So we feel that this is fast, intuitive, and fair. And then similarly, in addition to models, we wanted to create access to fair data sets that you could couple with the models. So we created Foundry, and Foundry builds upon Dlhub to make it even easier to incorporate machine learning into scientific research. So Foundry facilitates the reuse of data and models. We think it'll help with meta studies. It allows you to benchmark different models against each other and do similar things like that. And we feel that this has long-term implications for research and education. So let's say you had a user that wanted to publish their data set. They could do it in just one call to our Foundry package with the publish function. And that through Foundry would store it in a data provider, which you can choose. So one example of a data provider would be Materials Data Facility or NIST. And then similarly, a model publisher using Foundry with one line of code can publish their model to a model repository such as Dlhub. So here you can see this is kind of how Foundry wraps around Dlhub and similar services. And then a consumer who wants to find a model and or data can easily load the data set from Foundry and then immediately run it on a model that's also stored in Foundry. So you can do some fast science, which is exciting. So the models here can be run locally or on distributed endpoints in the cloud. And we have capabilities to pull data sets to the desired location or to move compute to a desired location. And so we feel that Foundry increases data interoperability and usability in a few ways, kind of like Dan mentioned. We have set metadata to describe the data sets. We have set metadata formats. And then we also shape the data sets for reusability. So this helps everything be a little more modular. And we specify and describe data environments. So those are collections of more than one data set that you need for a model or a task that we kind of bundle together so that you might have like a given data environment that you need for a given model or something. You can couple those. And then we also build those data environments. All right, thank you. That was my very fast talk. Both the Dlhub and Foundry are currently available for download from the Python package index, and both are in active development right now. If you have any questions or comments or just want to chat, feel free to reach out to me at this email down here, aristana@uchicago.edu. All right, stop sharing my screen.
Okay, thank you.
Thank you.
If, let's see, in the notes, there is a request for a link to your slides. So if that's possible that you can put in there, that would be great.
Sure, I'll do that.
I don't see any questions immediately. So if anybody has questions, please type them into the chat or the Q&A, and we'll just wait a second and see if we get anything.
Yeah, I will drop a link to the slides in the chat in just a second.
Okay, if you can put it in the notes document as well, that would be helpful because that'll be preserved better.
Sure. All right, thank you.
Okay, one question to you. Can anyone contribute models? Another
So
question coming as well.
anyone is able to publish models through our interface. So you just need to just set up a little account. And then once you have the account, you can authenticate anytime. I see there's another question. Is it okay if I just go through the questions? Dan?
Yep.
So a question, how do you quantify the fairness of AI models in Dlhub? That is a great question. We are currently working on how we might quantify it, but one way that we ensure fairness is, or I guess like assure fairness is by having like consistent metadata formats and consistent the data environments that I talked about. So, and also consistent shapes for the data. So we require the user when they publish their data to make it fit certain requirements that we have, and that allows it to be more fair. What storage limitations for source data sets? So currently, everything is built on Globus, which is like a large data infrastructure that we have that allows for moving both compute and storage around. And so right now we have what are called like our storage endpoints, which is basically like a location that we store our data. And right now we have large storage endpoints at the University of Illinois in Urbana-Champaign, and as well as some other areas, including like Theta, which is a large HPC supercomputer at the University of, oh, sorry, I'm just getting a little lost in the questions. But yeah, so not any set limitations because we can move things around. But I guess it's as limited as our most recent large storage set.
Okay, and the NSF part?
Do contributors have to be NSF funded? No, you do not. No, so anyone can contribute. Like a teenager on their computer can contribute. All of us can contribute. You do not have to be NSF funded. Good question.
Okay, so I think just in the interest of time, we'll go on to the next talk. And if there's more questions, please put them into the notes document, and then we can use that to respond. So thank you.
Perfect, thank you.
All right, so the next talk is actually a person who is not here. So I'm going to try to share a video.
Hi, I'm Joaquin van Schoren. I'm professor of machine learning in Eindhoven and one of the founders of OpenML.
Hi, and my name is Bernd Bischel. I'm a professor here in Munich of statistical learning and data science. I've been part of OpenML for a bit more than 5 years now, than I think. I'm responsible for connecting OpenML to the R programming language. Let me first introduce you to 4 different categories of objects that we usually deal with in machine learning. So there's not only data sets, this is like the raw data that we would like to learn on, but there's also tasks. So this is problem-dependent metadata, so this is target columns, this is evaluation protocols, resampling splits, and performance metrics. Then there's algorithmic flows. So these are descriptions of what algorithms we want to learn with in ML. So this concerns version numbers, dependency structures, and so on for the pipelines that we're using in ML. And then there's also algorithmic runs. So these are configurations of these flows, but maybe even more interestingly, algorithmic results. So model evaluations and also predictions.
Exactly, and all those data sets, flows, and runs, they're all over the place in different platforms, different papers. It's very hard to find easily and use the data sets that you're really interested in. And in OpenML, we want to build a platform that organizes all this information to make it universally accessible and useful. And we do that basically by building an API. So it's a web platform that allows you to easily share those data sets, flows, and runs from wherever you build them, from notebooks, apps, jobs, scripts. So whenever you're working on a data set, it's easy to share that data set to OpenML, and then other people can then download not only the data set, but also all the experiments and results that anybody in the world has created on those data sets.
Yes, and here is one way of accessing this API that Joaquin just introduced to you. So this is the OpenML web page, the web UI. And you can see that you can search here for data sets, for tasks, for flows and runs, and actually a lot of other things that we don't have enough time here to introduce to you in this brief overview talk. And you can search, for example, for data sets by name, by ID. There's static URLs connected to each of these objects, so you can link to them. And you can also search by data characteristics, for example, I don't know, size, whether the data set contains missing values, and so on. And then, of course, all of the results, these algorithmic runs, are connected to the data set of interest, and you can kind of already get a glimpse of how different algorithmic runs performed on the data set. As you get kind of a ranking view here and a performance aggregating view to get a feeling for what worked how well on the specific object.
And next to the web UI, we also have a very powerful API in Python, R, Java, and other languages. In this case, we have a very simple example, how we also integrate this into existing libraries for machine learning, like scikit-learn, TensorFlow, Torch, MLR, and so on. So if you use any of these libraries, it's very easy to share your results. So in this example, the first line builds a classifier, the second line downloads a task from OpenML by ID, third line then trains the models on these data sets, and then finally the last line publishes that. And those 3 lines do everything they annotate all the metadata, and push it to the platform.
Yeah, and what you can also do is now reproduce and reuse these runs. So you can share and rediscover all used data sets, flows, and runs on the platform. You can download them, investigate them, fully reproduce results, or start to tweak and change things, and then as good scientists investigate and figure out new things. So here, for example, you can see maybe Joaquin again creating his scikit-learn pipeline, creating an OpenML run by running the pipeline on a task and then publishing his algorithmic results on the platform. Now, what I can do is I can download the run, for example, by ID, and then extract the flow from that run and either reinstantiate it, run it again, technically reproduce this result, or more interestingly, maybe change this pipeline, change the data set, and run a changed experiment.
So OpenML has a large and growing community. We have over 150,000 yearly users, thousands of contributors. It's used in hundreds of publications, and we have several thousand data sets and flows and millions of runs. And you're very helpful. Thank you from all of us, and see you in OpenML.
Bye-bye. Thanks.
Bye.
Okay, so yeah, unfortunately with time zones and a bunch of other things, we couldn't quite get everybody we wanted, but we thought it was still good to try to get talks about relevant projects. So next, I'm going to assume that we're not going to have any questions on this. I'll try to do something with the video to add it to the shared notes document afterwards. Ari, I don't know if you want to come back for a second and say anything about a difference between Dlhub and OpenML. It's a little bit unfair just to ask you and not to ask the OpenML team, but if you have any quick comment.
Yeah, I think it's a little hard for me to say without knowing more about OpenML. I guess one key distinction, and I was busy getting the slides and putting them up for y'all, so I wasn't listening as much as closely as I maybe could have been. But I didn't catch if they also store data sets in addition to models. They do. Yeah. Okay. Yeah, I'll have to rewatch the video perhaps and look at their website to know. Okay. But yeah, sorry, Rainer, I can't answer your question more thoroughly.
Okay, well, let's go on to the next talk, which is from Vladimir on the Pistoia Alliance.
All right. Good morning, good afternoon, everybody. It will be just a second as I share my slides. So my name is Vladimir Makarov, and I represent the Pistoia Alliance. And I'll talk about a couple of projects that we run in the FAIR field as it applies to machine learning. Before I begin, I'd like to very quickly introduce you to the Pistoia Alliance organization. We are probably the biggest pre-competitive research alliance in the pharmaceutical sciences and industry worldwide. 9 out of 10 largest pharma companies are members of our organization, and the 10th company, you know who you are. So we have close to 140 commercial member companies and countless non-profit and academic members. And if anyone in this meeting is interested in our activities, please feel free to stop by our website. And the link is on the bottom of the slide. And also for convenience, I have placed all of those links that I quote in my talk into the shared document for this session. So this is a very quick overview of the Alliance members in AI and ML community. Unfortunately, I cannot honor every organization by placing a logo here because overall we have close to 600 individual researchers from multiple organizations that participate in our projects. The biggest and the most significant contributors are listed here. And this is the motivational slide. This is why we do what we do. Quality data is the foundation of machine learning, no matter how sophisticated one's model is. it is absolutely impossible to generate and make any use of it unless there is sufficient data to back it up. That said, let me go through two quick examples of our projects in this field. And they may look quite different from what you have seen in the previous talk. So our first example is the BioAssay FAIR annotation, informally known as data fairy within our organization. And here is the idea behind the project. When a chemist or biologist in the wet lab executes an experiment, they follow a protocol. Those protocols are described in research papers. They're also described in instructional pages that are listed with the assay kits that are produced and sold commercially. We estimate there are about 1.25 million of such bioassay protocols in existence today. Whenever you read a science paper that involves some wet lab research, the methods part of the paper will contain one or more such bioassay protocols. Overall, we have to admit that the quality of such publications is not very good. And the protocols themselves are not always reproducible. They are not searchable for sure. It is very hard to answer questions such as, for my favorite kinase, what are all the methods that cover all of the experimentation space? Today, to answer this question, you have to create a scientific review. It will probably take you months. It is going to be hard and expensive. So whenever you're starting a new research topic, there is a fairly steep learning curve. We're looking to address all the limitations of the current process of the publication on scientific protocols by converting them into machine-readable form. And that's the content of the project. Currently, we have 4 large company participants: AstraZeneca, Novartis, Roche, and BMS. We are also actively working with a couple of other firms. I have heard that FDA is showing interest in this topic as well. So going forward, we plan to scale up this project from hundreds of assay protocols into thousands, eventually tackling the 1 million protocol challenge, right? And also to create a data standard that we want the entire community to participate in and to buy into, so that the future protocol publications are actually fair. And the link to the project is on the bottom of the slide, and you can also find the same link in the collaborator document. My second example of a Pistoia Alliance project in a FAIR space. Some time ago, we published a FAIR toolkit for the life science industry. And this toolkit contains 12 methods listed in this slide, and they apply to tools, training, and change management. So they cover both the technical and the business aspects of converting one's organization to more fair practices and greater degree of maturity in FAIR. And as a matter of fact, among the tools, we have 4 FAIR maturity indicators for each of the 4 components of FAIR. The participants in this project are listed on the bottom of the slide, and as usual, there is also a link. At this moment in time, the FAIR toolkit has 5 use cases listed here. Each of the use cases is quite involved and quite interesting. I regret that I am not able to cover them in depth today. But as usual, if you follow that link to the Pistoia Alliance site, you would be able to actually click on those things and read them in detail. And the FAIR assay annotation is already attempted as one of the use cases here, and it will be expanded in the near future. This closes my very quick talk. My email, if you're interested in any follow-up, is also posted in the shared notes. And I thank you very much, everyone, for listening, and welcome your questions.
Okay, thank you very much. Any quick questions? All right, I don't see anything coming for the second. Yes, okay, one question.
What's the connection between companies and fairness in ML? Just making sure I understand the question right. I think that multiple commercial firms discovered the value of making the data, the models, and even the experimental protocols like I've been referring to easily findable, accessible, interoperable, and reproducible, right? And so that's where they see the commercial value, and they actually invest in that space. I don't have the specific figure for the commercial, for individual commercial firms, right? But I have an aggregate figure for the European Union that I think was published last year. It's estimated in about 10 billion euro. That's the cost of either lost opportunity of not having data fair, or the gains that one can make if all research data was made fair. Is it for internal purposes or to share data and models with researchers? The answer is both. For internal purposes, first and foremost, because these companies are in business of making money. And secondly, yes, there is a desire to share. It is, of course, limited by the business purposes of our member organizations, but there is a desire to share. As a key example here, the BioSA protocols that we annotate will be shared with the entire community, and very shortly you would be able to find them in PubChem and subsequently in Campbell, because the data are shared between those two public data banks.
Okay, so there's one more question, but I'm going to ask maybe if you can answer it in the collaborative notes so we can go on to the next talk, which is Jen Harrow on Elixir. So thank you.
Absolutely. Thank you very much.
And Jen, go ahead when you're ready.
Hi, good afternoon or good morning, depending on what time zone you are. I'll just set up my slides now. I assume you can see these slides. Please let me know if you can't. I'm Jen Harrow, the tools coordinator at Elixir, and I wanted to give you an introduction, a little bit of an overview of Elixir, because I know with RDA and some of the workshops, there's been a little bit of querying about Elixir, and then I'll go into what the focus of the machine learning group is. So just to introduce Elixir, its focus is really establishing a sustainable infrastructure for managing and analysing life science data at scale. And currently we have 23 nodes, which equates to 22 countries, and one EMBL EBI is treated slightly differently because it's got so many infrastructure resources. So it's a node on its own. That's the reason we have 23. As you can see from the diagram, we have 23 countries, but we have a lot more institutes. We have around 220 institutes leading in bioinformatics that take part. And we basically provide the people and technical capacity to enable data stewardship around life science projects. Elixir was established in 2013, and really its first program, which was a 4-year program, was funded by the Elixir Accelerate grant from the EC. And really the aim there was really to establish platforms and use cases which have now turned into communities. So we initially had 4 use cases that has turned now into 13 communities are now starting to be established in Elixir. And we're now going into our second phase of Elixir, which is now not just establishing, but it really is deepening the partnerships with the communities and the platforms and really looking around new areas to get engaged with. And this is why we're turning into looking at AI and machine learning, as well as other things like biodiversity and single-cell genomics. And so just to highlight, Elixir is really all around engagement and participation in bioinformatics and around data. As I mentioned, we have engagements around the platforms for the Elixir members and also around communities. But now we've set up a more agile grouping, which is called focus groups, which basically non-members as well as members of Elixir can take part in. So these are starting to be bigger groups where also industry can take part, really to give us some input. There's no funding involved, so that's why non-Elixir members can take part. But the advantage is networking and workshops as well that they can take part in. So we set up recently the machine learning focus group, and Photos, who's taking part in this workshop, is actually one of the chairs of this group, along with Silvio Tossato. And the main goals of this group really is to agree on standards for machine learning. And this is really in response to a publication from David Jones, who published in 2019 a publication in Nature Reviews for Molecular Biology, and stated the question that really we should start setting up some standards around machine learning in biology. And so we've been discussing this as well as around machine learning for FAIR principles and around reproducible machine learning as well. And in collaboration with the tools platform, we have a benchmarking software that we think could help with machine learning tools as well to benchmark the quality of these. As well as with the training platform, where we found out, of course, machine learning is a weakness that a lot of people want to engage with. And so we're engaging with the training platform to see what we can do to improve capacity building around that area, as well as engaging with the Elixir communities around machine learning. So we currently have over 40 members that take part in the machine learning focus group, and this is represented with over larger than 10 different countries that take part as well. And one of the outputs that we've already been successful with is the DORM recommendations, which I'll go more into detail a little later. But also we have connectivity with Story Alliance, with the presentation that Badri has just made, and also Orkin as an industry partner as well. And just to highlight, we've recently submitted to Nature Methods, we've got accepted DORM recommendations for life science. And this is really producing a kind of checklist for reviewers around publications, because as highlighted in the Dlhub presentation, there are an awful lot of publications now around machine learning, and it's really to make clarity around these publications for reviewers and what checklists can they provide. And so we've come up with the DORM recommendations that stand for data, optimization, model, and evaluation. I'm not going to go into great detail here because I haven't got the time, but we have got the publication in archive, and the link is on the slides that you'll be able to look at later. But to highlight, we would love to kind of collaborate with Dlhub around models, because we totally support that the models should be accessible and also interpretable, and it should have availability of software. It's part of one of the DORM recommendations. So just to give you an overview of what we're thinking of doing for the roadmap for the machine learning focus group, we have some short-term activities which are around registry for the data sets that are being used in these machine learning papers. We're trying to set up a registry around the data sets that are being used in life science and links to these data resources, as well as connecting and reviewing these gold standard data sets to see how they're relevant to the community, and engaging with the communities if they have more data sets that they can recommend that we should use. As well as thirdly, looking at synthetic data. There is an important area here to use synthetic data, especially in the health data realm where you can't exchange genomic data, then synthetic data can be used instead. So we're also engaging with relevant groups there to look into that. And in long-term activities, we're looking around the governance around machine learning standards and the DOME recommendations, because we think some of those DOME recommendations could change depending on which community you engage with, and we could increase them as well. So we need some governance around these standards to improve, and we would like to engage with Claire, Pistorial Alliance, and Keepo to talk about these things, as well as implementation as well. So we're thinking about having our DOME recommendations as implementing them as a machine actionable version that can be used by researchers as well as publishers as well, and start engaging with publishers about how they can engage with the DOME recommendations. So finally, I just want to acknowledge the people involved in the DOME recommendations and all the people that have been engaging with the machine focus group, the machine learning focus group. They've been really very enthusiastic. And as I say, you can get involved, so please send an email to the link or have a look at the website. You can email me. I definitely recommend that you get engaged because it would be very useful for this community. And thank you.
Okay, thanks very much. Let's see, looking to see if there are questions in chat or Q&A, which I don't see for the minute. Yes, a question then from John.
Thank you for your talk. Does Elixir plan to include machine learning for protein folding predictions? Yes, that is also a community we can get engaged with. We have a proteomics community, so these kind of specifics around the different communities we're definitely are going to get engaged with. And if you're interested in joining, please send me an email. We can get you engaged.
Okay, not seeing anything else for the second. Thank you, Jen. And we will
thank you. You're
go on
welcome.
to Elio.
Share my slides. All right, so I hope that you can see the slides. My name is Elio from Argonne National Lab, and I want to talk to you about a project that is called FAIR for HEP. So let's see what this is. So our team, FAIR for HEP, is, as you can see in this slide, a multi-institutional team. We bring together diverse expertise from data science, AI, physics, and we believe that by creating this interdisciplinary team, we can understand, or at least try to integrate the knowledge that has been gathered by the FAIR community into a specific domain, which in this case is high energy physics. So here the name of the game is as follows. There are physicists that understand very well challenges in the application of AI. Have experts in the team like Dan Katz that have been working on understanding how FAIR applies to software. And now the question is, can we try to integrate this knowledge and our expertise in AI and innovative computing to create a framework where we can gradually bring our community up to speed with how we can collect or produce FAIR data sets, and then how this can be used to maximize AI for discovery. So we have heard about what FAIR means. These are the data principles that have been in discussion for a number of years. But how do we go and try to create or apply these principles in of high energy physics, or if you want, in any other domain? What does it mean to have a FAIR data set? So this is what we are going to be trying to do through this project. And what we have done so far is to interact with members of the FAIR community, understand the tools that have been developed so that we don't create a wheel. And so we have encountered some specific tools that enable us to quantify or assess when a data set is fair. And the goal of this, if you just step back for a moment and think what is the big picture of this, is that when you create fair data sets, what you are doing is you are saving a lot of pain and wasted time in the future, because if your data sets meet these metrics, then that means that the scientific data sets you play with will be reusable seamlessly by both humans and machines. And this is going to be critical when you are training AI models, right? If you understand all the properties of the data, if, for example, the data comes from an instrument, you will know whether the data is good enough for training, or whether the instrument was not perfect, you should not use that data. Or when you're doing inference, you are going to understand whether the results are good because the data is sane, or it is contaminated and you should discard it, etc. Now go to the step where you have fair data sets and you're creating your models. So at that point, since you have a good understanding of the data, you can go and try to unveil new connections between data and models. Questions like, is the complexity of the network that I am using sufficient or maybe too much for the type of analysis I want to conduct? Can I get a better understanding of the architecture if this is a architecture or optimization scheme? Can I actually learn anything from the data and in the way I am designing my models? Can I understand why the neural net is making these errors or why it is doing things correctly? This type of understanding that at this point is not clear. And at some as a byproduct of this work, what you're going to end up with is with AI models that can be interpretable, they will be domain informed, and they will also adhere to these FAIR principles. And I will show you in the end where this can lead to. So why are we doing this? Well, we have heard in the previous talks that producing FAIR data sets is essential in a number of disciplines and even in industry. If you want to train a model but your data set is not readily usable, you're going to waste time trying to do this, pre-processing the data sets. That should not be the case. We hear often from researchers, can we use these data sets in a seamless way, meaning they are AI ready? And what they mean by this is the following. You have a facility, maybe a simulation, you produce the data sets, and what we want to do as AI researchers is to bring these data sets and use them right away to train models. We don't want to do any pre-processing, that wastes time. And so when you're also processing these data sets to extract knowledge, to make predictions, again, you don't want to waste any time with pre-processing. And you also want to understand whether those data sets are good enough for an analysis. If metadata information states that at that time an instrument was underperforming or it was out of log, etc., you just don't use that data for an analysis because your conclusions will be wrong. And so the specific...
Maybe one more minute?
Yeah, sure. So what we're trying to do at this point is to develop tools and metrics that will enable researchers to do this at a scale. We will not transform all data sets into a FAIR format. So in a way, we are just providing the tools to automate this in the future. And we have some ideas about releasing these models through Dlhub, and then talk with researchers about how they can leverage the Dlhub and PhunX to be able to conduct reproducible data-driven analysis. And we hope that 2 years from now, we will be able to fully understand what it means to apply FAIR principles for data sets and models, and how this can lead to discovery. And let me just finish acknowledging DOE, because they are the ones that are supporting this research. And that's it.
Okay, thank you. Any questions? Okay, I don't see anything appearing immediately, but maybe we'll check the Google Doc as well as we go on. So thank you. All right. So next, Tom about Claire.
So let me share my slides. So voilà. Hello, everybody. Thanks for inviting. It was quite interesting so far. My name is Tom Leenaerts. I'm a professor in AI, machine learning, and bioinformatics from the University of Brussels. I belong to many different associations, so I'm not going to talk about them, but I'm going to talk about Claire. And before, of course, I can talk to you about Claire, I need to first introduce to you what Claire is all about. So Claire actually is a confederation of laboratories for AI research in Europe. And it has as a goal to become the global lead in human-centered artificial intelligence in the area, with the ambition, of course, to make AI systems or to do AI research that actually benefits society, but also that everybody can benefit from the products that actually are produced by these AI tools. That's why it's also AI for all. At this moment, Claire is the world's largest AI research network. There's more than 290 groups involved across all Europe, which comprises over 20,000, more than 20,000 AI research and support staff from 35 different countries. So there's more countries involved than actually Europe has. So this shows you the importance also of this network. And there are also many individual supporters, also EU countries that actually express their support for this initiative, as well as some of the leading European international institutions. And so to realize this goal, Claire has, which is actually quite young, so it actually started not so long ago, but it has played a major role in Europe's action plan for AI. So today, there was this AI regulations launched. Check LinkedIn and Facebook, and you will see this popping up everywhere. But Claire was involved, for instance, in designing this first white paper on AI and AI action plan for the EU. It's also very much involved in stimulating innovation and leveraging knowledge coming from academia towards EU businesses. And that's also why it's playing a key role in the European plans for public-private partnerships. And here on the right, I show you a bit the current ecosystem that exists on AI and machine learning research in Europe, which has been largely financed recently by an EU called ICT48. So you see there in the center 5 important new projects, which are AI for Media, Taylor, Elise, Human AI Net, and Vision. And these all cover different aspects of AI and machine learning. So one of them is about the link with media. Other one is thinking about building trustworthy AI systems. Other one is thinking about linking this to societal problems. Like this is the Human AI Net. And everything is a bit brought together by this vision coordination task that actually is run by many people belonging actually to this Claire network. And this brings together also all the existing groups like the new AI innovations hubs that are going to be established in the European countries, and also with robotics and big data science shown on the bottom. What I want to highlight to you here in this ecosystem is the AI for EU, because all the things I heard until now from the previous speakers was about creating platforms to actually share either data and models, or only models. And this is also exactly what is done by AI for EU, but then for all of AI. So not only for machine learning, but for all of AI, which might be interesting to look at and if you want to know more about that. So from a research perspective, this includes, of course, anything that has to do with learning, reasoning, and the interactions that actually are needed between agents or between robots or between human and agents to establish intelligence. Clearly, the goal is here not to replace human beings, but it's actually to augment their intelligence. And this can be, for instance, in natural sciences, but also in biological science or medical sciences and so forth. Of course, the OpenML was already here. I mentioned AI for You. There's a lot of initiatives happening. So when discussing FAIR for ML, it's important to take into account what's already out there. Clearly, this has been done here by the organizer of this workshop. This was very nice. And me, I'm actually representing the people developing this ML model. So I'm quite interested to see how you, from your perspective, think about the models we develop. And so I'm actually then able to building the ML models and inventing new algorithms to actually see what they have to do in order to ensure that their systems are fair. And I really like this paper by Lamprecht et al. In Data Science, which actually is discussing software, but it might also be applied to certain aspects of machine learning. But maybe a question I want to raise here is that if I read those articles, I see mostly discussions about standardization of storage and adding metadata and putting unique numbers on these kind of systems. But if you think about AI and machine learning, than just registering these things in database so that you can find them. Since it's no longer simply software, it's systems that don't give you full control but are making predictions, you have to take into account that these systems make errors, that they're not always correct. So there's an important issue here about trustworthiness about AI and machine learning tools. And it was mentioned before, reproducibility is a central problem, and it's not useful, it's not helpful, this problem, because it decreases trustworthiness. And for instance, it was mentioned, just take any paper from an AI conference or a machine learning conference and try to reproduce what they're doing. It's sometimes quite difficult. And even if they provide the code, you cannot test this in 5 minutes. You need particular kind of platforms. You need to know the exact parameters that they used. They might have forgotten to mention something. So these are things that probably all of you know as well as I do. There are, of course, initiatives like the DOME recommendation to try to say all the information you gave on how to build this system. But be aware, we are moving to no longer software being programmed by humans, but software being programmed by systems. What are you going to do with AI systems producing ML models automatically? How are you going to make them fair? I clearly agree with what discussions that have been going on before in this session, and that you need some good ML engineering practices in order to make sure that these things can be reproduced, are understandable. You need to make things like design patterns. There's a nice project that I want to mention here, is the software engineering for ML by one of the founders of Claire, Holger Hoos. You might want to check that out because they're trying to collect software engineering best practices towards ML. You might also want to think about how to incorporate verification approaches, so how to test that the software is producing the output it's claimed to be producing in an automatic manner. And of course, we need to find a way to improve the uptake of trying to make machine learning fair. And this can be done either by this FAIR paper, but also to try to learn our students or practitioners about what these best practices actually are. And so in short, and I'm sorry if I'm too fast, Claire as a machine learning producer, is an AI producer, is of course supporting FAIR ML, but there has to be some good discussions about what this would mean in the future. And I thank you for your attention, and I'm open to any kind of questions.
Okay, thanks. Any questions quickly?
And I'm apologizing if I spoke too fast. It's a bad habit that I have.
Okay, I don't see anything showing up for the minute. So
if you have further questions, the slides are in the document, and you can always send me an email.
Okay, and so the last talk that we're going to have from Julian, we've had a registration difficulty, unfortunately, but fortunately he prepared a video as well for the repeat session, so I'm just going to play that video. So give me 1 second.
Hello, I am Julien Gagneur from the Technical University of Munich. Predictive models are catalyzing progresses in genomics with applications spanning raw data analytics such as variant calling, but also bioengineering and genotype interpretation. However, and in striking contrast to previous efforts to share data or libraries and software, the genomics community has mostly relied on individual solutions to share trained predictive models. We argue that the FAIR principles also applies for trained predictive models. To address this need, we have initiated KIPI, a repository of trained predictive models, together with the labs of Anshul Kundaji and Oliver Stegle. KIPI models are simply shared as a YML file describing the trained model. Trained models consist of a model component, a parameterized mathematical function which can be implemented using a variety of ML frameworks, thereby serving the genomics community rather than specific developer communities. Model architecture and weights are stored on data repositories like Zenodo, ensuring immutable and long-term access. Models come along with data loaders, which abstract and unify the preprocessing of data stored in bioinformatics file formats, yielding numerical representation that can be used as model inputs. We use Conda to manage dependencies. Models are subjected to nightly tests and test on merge request using a continuous integration service, thereby ensuring that all models are executable and yield reproducible outputs on test datasets. General model information, including a simple application classification, facilitate the browsing of models on the repository website. Each model is stored on KIPI's GitHub repos. As of today, groups covering over 2,000 individual models across various genomics areas. KIPI models can be accessed via Python, R, command line interface, or as Docker containers. Typical applications include seamless benchmarking of models. Here is an example for comparing transcription factor binding predictions across various models, which is achieved with a generic command line. Another very much needed application is genomic variant interpretation. This can be achieved in a quite generic way by leveraging KIPI's variant effect plugin. For modelers, transfer learning is an appreciable application whereby new models can be quickly built starting from related KIPI pre-trained models. Last but not least, building ensemble models, for instance, to score variance by combining existing models can be quickly done thanks to KIPI standardized data loaders. We keep updating and populating KIPI. We are also running a monthly web conference on deep learning for genomics. Visit kipi.org for details. In conclusion, KIPI is implementing the FAIR principles for trained predictive models in genomics, which we hope will help the community to collectively build better genotype to phenotype models. Current and future development include expansion of the repository and better integration into bioinformatics infrastructure. Here are the people who contributed to this work, but thank you for your attention.
Okay, so we're a little bit behind where I thought we would be. Sorry about that. I will also try to make sure that all of the slides and videos are linked from the session on the RDA site in the agenda. But it'll probably take me a little bit of time after this. So that should happen sometime in the next, hopefully, day or so. The remaining time, what I wanted to do, which I hope is acceptable to everybody, is to kind of talk about next steps, to say that we clearly have a number of projects that are interested in sharing machine learning models and that seem to want to do it in a fair way, or at least to define what fair means. And so there's really 4 questions that we were thinking about. One is, does continued discussion make sense? And in the collaborative notes document, we've created tables where if everybody can kind of put in some comments, if they have comments about, does it make sense to keep talking? There's one question. Second question, should we propose an RDA interest group or a working group for this, or is there some other way that we should continue a discussion if it does make sense to continue? Maybe RDA is not the right place. Maybe something else is. Or if it is RDA, is it a working group? Is it an interest group? Is it something else? Another question is, who else should be involved? So projects and people. There's an interesting term for how we assembled the people that are giving talks here, which is kind of snowball sampling, which is that you start with a kernel and you kind of push it downhill and you see what gloms onto it. And so we started with a few people and people that responded to a tweet, and then people they suggested. But I'm very sure that there are relevant projects and relevant people that we did not invite and that don't know about this. And so who could those people be? Who else should we be kind of trying to bring in? And then the last question, again, at the very end of the collaborative notes, is my interest is in getting this to happen, in having this discussion and having a community come together and either say that we need to define a new set of FAIR principles for machine learning, or say that the data principles are good enough, or that the data principles are almost good enough, and we just need to add something from the software principles or something else. But I do not want to be the person necessarily that leads this. And so if there are people that are really interested potentially in leading this group, with certainly with me supporting it, and I think with Fotis maybe either co-leading or supporting, and maybe other people are here as well, that would be great. So I think my guess is that some continued discussion is going to make sense, and that we kind of need somebody to take charge and push this forward, even though there are a lot of us that want to contribute to it and want to support it as it happens. So just, so I'm happy to see a few people starting to type. We need to make some more rows in some of these tables, which I can try to do. And as people are typing, if anybody actually kind of wants to say anything verbally, feel free to also to unmute and to say something, or to type something in the chat as well. In particular, I think if anybody thinks that it doesn't make sense to keep talking about this, that would be really interesting to know why not, because that would kind of cut off some of the other discussion. Yes, Tom wants to ask a question, so please go ahead.
So wait, yeah. Okay, my question here is, we saw a number of talks of people presenting platforms on how to make things fair. My biggest worry is that the number of platforms will grow over time, which will result in fragmentation. So could there be any initiative to try to streamline these things that are actually committing to the same goal, and trying to make sure that we don't have like 17 different tools that people are using for doing exactly the same thing?
Yeah, so that's a great question. I'll just say, kind of personally, my opinion is to have multiple tools and multiple platforms actually is fine, as long as they're interoperable and they kind of sign up to some sort of standards. So in some ways, if we could do something like re3data.org for these platforms, maybe that would be an answer, so that you choose whatever platform works. Maybe it's one for your discipline, maybe it's one for your institution, but we can search across them and we can run across them. I don't know if we're really ready for that. It seems like the platforms maybe have some differences that need to kind of get worked out, and maybe we're in a stage where we need to have a bunch of flowers that are blooming, and then we decide which ones we want to cut off. No, which ones we want to fertilize. Well, something. Other comments from anybody that, again, wants to say anything? In addition to typing, please feel free to unmute yourself and speak up.
Just to follow up on what Tom mentioned, sorry. I would tend to agree that having multiple platforms at this stage is not the problem. So the discussion I would be very interested to listen and to contribute is how to essentially start defining the standards for the FAIR principles in machine learning. So in other words, there's definitely some overlap between the interpretation of the FAIR principles for data and machine learning, another overlap between FAIR principles for research software and machine learning. But I also think, I'm not absolutely certain, but my impression is that there is a unique aspect for machine learning that is not yet captured in either of those cases. So the first question for me would be to identify those elements. And based on those elements, then we can start discussing how the different platforms that are out there can start possibly connecting to each other or being supporting each other, because I think some of the platforms that we've seen so far today, they do have a complementarity there. So it might be even an advantage eventually to have a way that these platforms can be connected beyond a purely technical perspective, that is. So that's sort of my take on that. Yeah, meta-fair between platforms. Yeah. Thanks, Tom.
Yeah, I mean, I think that if we think about FAIR for data, it's not something that you can just do as a data creator. It needs the platforms to be involved as well, and the platforms have to have to support the standards, but have to do it in a similar enough way. So I'm not, I don't know. It seems like maybe we're in a similar situation here. We just don't have enough experience. But question. So just looking at the comments, I don't see anybody. I'm sorry, Tom, do you want to go ahead and say something?
Sorry to interrupt you again, but maybe Daniel, you maybe have experience with how these things are done in software context, right? So would what is required here be extremely different from that case, or not really?
That's an interesting question. So in some ways, we may be similar to software in that we have a set of platforms that are in, well, at least in software, we have a set of platforms that are in extremely wide use, and in some ways, the platforms kind of drive things. Here, I guess, in data, well, yeah, I feel like here maybe we're in a little bit of a different situation where the platforms are newer and none of them are really incredibly widely used. So I'm not sure. Again, I mean, I think that there's a lot of good work that's been done, and the platforms that exist are clearly useful. But I don't know if we've had enough time and enough experience to know if kind of there's a right model in some sense for platforms or a right API for platforms. Okay, so again, kind of just looking at comments. So no one's unhappy with continued discussion, which is good. We have some support for, it looks like, for a working group with a comment from Amy about talking to the VRE group. Let me get to John's question in a second. Don't have very many suggestions for other projects that should be involved. At least one from Mark, and ML4AU has shown up. It seems like there must be more. I mean, we kind of have had people talking about life sciences and physics here, and it seems like there must be more going on in the geosciences and astronomy and other areas. But I don't really know what that is. So if anybody does, again, please feel free to answer to put that into the document.
Hey, Dan, this is Mark. I'm really just sort of on the periphery of this, but there's definitely things bubbling up in the earth sciences. There's a group within NASA that is looking specifically at the training data aspect, not necessarily the models, but making sure that the training data are interoperable and well stewarded. And then there's sort of a related group within ESIP that just spun up. I think Douglas Rao might be on the call. He could speak more to it. And it's talking about AI-ready data. So really looking at the data aspects, but I'm thinking more and more that it doesn't make much sense to consider the data and the models and the platforms independently. I was very impressed by the first presentation. That really you need to think about the whole package. So what little I've seen in the earth sciences, I don't think it's gotten to the point of sophistication that like we see with Dlhub and stuff, although there is some stuff going on, like that's what that Radiant ML is. It's among other things, it's a hub for training data sets, specifically in, earth sciences, remote sensing in particular. So that's, a little bit of what's going on.
Okay, thank you. Again, if anybody else has any specific groups that we should be contacting, please put down the groups in some way of contacting them. That'd be great. Fotis, I think you came on before as well. Were you going to say something as well also?
There are a few comments on the chat window that may be interesting to pick up, and one question in particular from John, which is how will we handle commercial entities that are doing demonstrably important work, but maybe not aligning so well to FAIR? And the question here is about DeepMind, for example. From my side, the argument I should say here is that it's not the purpose to change the way any one entity wants to work, but rather identifying what is the appropriate way to ensure fairness for machine learning generally. And if one wants to adopt that, that is actually excellent. If they are not open to the idea of adopting these, again, argumentatively fair for machine learning principles, then it's up to them. The question that I personally have in mind is, I'm not sure what the fair principles for machine learning are or should be to ensure that part. So,
okay. Siri, sorry, I hope I'm saying that okay. Can you put your comment in the collaborative notes document as well? Unfortunately, it's not possible to copy from the chat, so I can't just paste it in. But if you can put that into that question C at the end, that would be great.
Sure, will do.
Thank you. Right, and Eliu, I think Eliu's comment is great, that in some ways, if we were doing this as a working group, it needs to kind of connect back to all the different communities. We can't just focus on the people building the platforms. And the crossovers of the VRE group makes sense, and we can certainly talk to them and bring them in. That seems good. Yeah, I don't see anything else new in the chat. Let's see, just looking at the document again. Right, I don't see anything new that's been added there. Right, I guess this question about that Neil has added in item A about if we're concentrating on models or platforms or FAIR is certainly a good question, and I have very little idea what the right answer is there. I don't know if anybody else has any thoughts about how we might focus. I mean, we could also leave that until we actually start a group or start discussing a group and have that discussion as part of the discussion of a potential charter.
I quite like this question. Personally, I would not focus on the models, but again, this is a very personal opinion. But I think, and being mindful of the time that we have like 4 minutes left, it may be useful to sort of see what the most appropriate next step might be. In my opinion, based on the discussion that I've seen here, I think that a first structure for the working group might be in order. At least figuring out an outline of what the scope and the object might be might help us also structure if a working group actually makes sense to have in the first place. So starting working on that will be my first sort of.
Okay. Okay. So thank you. So as we're running out of time, I guess I just want to say. Sorry, I'll just answer Eliu's question for a second. I don't think of Dlhub as being particularly local. I don't think it's intended to be US focused. So the idea of a counterpart in Europe doesn't necessarily make sense to me. But the idea of organizing fair data challenges, maybe from multiple platforms working together, seems like that would be a really interesting thing to do. So we should capture that in our notes. So what I was going to say is that in the beginning of the notes, a lot of people put in information, and some people did not put email addresses, some people did. If you want us to contact you as we go forward, then please add your email address if you didn't, because that'll help us start a list at least of people to talk to about this working group. So other than that, I think, yeah, so I agree with Tom that OpenML and Dlhub certainly have overlaps, although they also have differences, but I don't think that either one is intended to be regional or discipline specific. I think they just have started separately and have kind of grown in slightly different ways. Right, I think they're both open to all, and others maybe as well. Okay, so yeah, so thanks again. Thanks to everybody for coming. Again, add your name and email address if you want us to contact you. And it seems like the feedback that we have is that either Fotis or I probably will at least start contacting people, and we'll see kind of how we go forward. And again, if we can maybe find some additional co-leaders potentially with the Fair for Research Software Group. It's been great to have 9 co-leaders. It really has helped make things easy where nobody has to kind of pick up all the weight and carry it. So hopefully we can do something like that as well here. And yeah, and so I think, again, thanks to everybody that spoke. We will do a repeat of this in breakout 9, I believe, which will be mostly videos as opposed to talks because the time zones are bad for people in Europe. But we'll do a similar discussion at the end. And so if anybody wants to come back and have more discussion, please come back for that session as well. Okay, and with that, I'm going to sign off a minute early and thank everybody again for coming.